Okay, hello everyone. Welcome to webinar on box culvert analysis using MIDAS nGen. This is one of our last sessions in the training session, MIDAS nGen training sessions. So let us go ahead. If you have any questions during the session, then please write here at the questions box. In today's webinar, we are going to be having a small introduction to MIDAS nGen software solution, and we'll look at its application areas and have a small demonstration on how to analyze a box culvert in MIDAS nGen and design. Then I'd like to tell you about MIDAS support services, and further we'll conclude our session and we'll see a special launch offer on MIDAS nGen. And after that, we'll have a question-answer session. Firstly, I would like to tell you what all programs MIDAS as a company offers. So MIDAS has four main family programs. One is in bridges, structures, geotechnical, and mechanical field. Under the bridges, we have MIDAS Civil. The box culvert that today which we are seeing is possible in MIDAS Civil as well. However, you can call MIDAS Civil as the core software for bridges, when you can do all types of bridges in a very short period of time. So it can be simple box culvert or slab bridge, or it can be complicated extra doors bridges or suspension bridges or cable stayed bridges. You can perform analysis and design as per the standard. Then we have MIDAS FEA for advanced nonlinear and detailed analysis systems. So in case of any locations like joints in MIDAS Civil, the stress analysis is really important, so that nonlinear stress analysis can be performed very easily in MIDAS FEA. Then further coming to the structures, we have MIDAS Gen and MIDAS nGen software solution. MIDAS Gen is our older software solution. MIDAS nGen is the latest one. So soon we are going to be converting Gen into MIDAS nGen. All the capabilities of Gen will be coming to nGen. So let's see what MIDAS Gen or nGen is all about. Basically, it's a software solution in which you can do buildings as well as general structures. Then we have MIDAS Drawing. The analysis and design results from MIDAS Gen or nGen can be taken into MIDAS Drawing for creating drawings and also generate bill of materials. There is MIDAS Design Plus software solution, which is a structural component design and detailing software solution. So in case of any simple slab design or footing design, beam design, column design, individual one, if you have the analysis results with you separately, you can perform the design and also generate drawings out of it. Then coming to the geotechnical field, we have GTS-NX and SoilWorks. GTS-NX is a 3D finite element software solution, whereas SoilWorks is a 2D finite element software solution. 2D, it's not just 2D FEA, that is not just finite element, but also analytical geotechnical solution. Coming to the mechanical field, there is MIDAS NFX and MIDAS FX Plus. NFX, you can use it for impact analysis, or you can use it for 3D computational fluid dynamic analysis. To simulate wind tunnel test results, you can use MIDAS NFX. Then further, there is MIDAS FX Plus, which is a preprocessor for creating complicated geometries in a small period of time, and then we can import the model from FX Plus to all MIDAS software solutions. One good part about MIDAS software solutions is that all the programs are integrated with each other. You can take the model from Civil to Gen, Gen to Civil. You can take models from MIDAS Civil to MIDAS FEA, even MIDAS Gen to MIDAS FEA, and vice versa. And then further we have GTS-NX software solution, which is a 3D software solution for geotechnical analysis. You can have the integration between GTS-NX as well as MIDAS Civil and MIDAS Gen, so that you can perform soil structure interaction. So all these interconnectivity helps us to work very efficiently with all aspects of our structure. Let's go ahead to MIDAS nGen, which is our today's topic. MIDAS nGen is the next generation solution for building analysis and design. Even though it's for buildings, we can also use it for general structures. So today we are going to be looking at the box culvert analysis and design, which is actually a type of a bridge, but we can use it or we can create it in MIDAS nGen, and we can further go ahead perform the analysis and design for that structure. Alright, so basically MIDAS nGen comprises of analysis tool, design tool, as well as drafting tool. Yes, we can generate the drawings as well after we have performed the design out of the analysis in the same software solution. So you do not have to go for multiple softwares, just one software and you have it all. The most important concept of MIDAS nGen is from drawing to structural drawings generation. Alright, this is more applicable in case of buildings. So basically we have the integration wherein all processes are carried out in MIDAS nGen software solution itself, and everything can be done in one. You can have superstructure as well as substructure in one software solution itself. Then there is automation, wherein there are various automatic processes in MIDAS nGen that can reduce the production time significantly. Optimization, when it comes to RC buildings or steel buildings, that time we can optimize those members as well and thus get enhanced optimized quantity takeoff. And coming to the reports, we have high quality of design deliverables. You can generate good reports using Report Maker and get it into Microsoft Word directly. And also you can generate structural drawings. Let's look at the application areas of MIDAS nGen. Because of the automation and the optimization processes from modeling to report generation that provides a multidisciplinary and fully integrated solution for structural design, we can see so many applications of MIDAS nGen. So we can have apartment buildings, and this is an example of the concrete frame with steel roof. It's a car park and building. So that's the thing. Then further, a multi-towered structure can also be done in MIDAS nGen, and a shelled structure can also be done. So today's session is going to be on box culvert, which is nothing but a shell type of a structure. And today we will have a demonstration on this box culvert, as you can see. Alright, so we are going to be taking one part of the box culvert for the analysis. Let's go to MIDAS nGen to see how the drawing will be, how the modeling will be done in a very easy format. And before we go ahead, I would like to just tell you that this is how we are going to be creating our box culvert. Basically, we are having our box section in this way, and we are going to have a skew angle as well in the plan view. Alright, so accordingly, let's go to MIDAS nGen. Alright, so we are in MIDAS nGen right now, and if anyone is new to our webinar series, then I'll quickly explain the user interface of MIDAS nGen. The user interface of MIDAS nGen comprises of the ribbon menu at the top, which is divided into several tabs. But don't worry, these tabs are arranged as per the work procedure. From left to right, you finish with the entire modeling, analysis, and design. So first 4 tabs you can see here are for the modeling. Then you go ahead to the loading, then apply the boundary conditions like supports, spring supports. Then you can perform the analysis, perform the design, and check the analysis and design results, and go ahead further to generate the reports and drawings. So from left to right, you finish with your entire structure. Then further over here, we have got the works tree, not the works tree, but the tree menus. You can have 5 tree menus over here. One is the model tree menu. In the model tree menu, you get to the information related to the modeling parts, like everything about the properties and the scale factors and what all members are there, the stories and everything when it comes to a building structure. All right. Then we have the analysis tree menu. In the analysis tree menu, we get the information regarding the boundaries and the load conditions and any functions applied to the structure for the loads applied, and also we can get the analysis cases that we create. Then we have the design tree menu, and in the design tree menu, we have got the information regarding the design groups, the load combinations and design cases. We have the display tree menu, which can help us change the displays by just clicking and also going at different views by creating those views. And in the table, we have the information of all the structural loads, boundary conditions, structures like members that we have on our model under one hood. So you can access to all the tables from this table tree menu. Over here we have the properties bar. So in the properties section, you can say over here, when you click on any of the member, you can get entire information related to that member. Most important or good advantage that we have in MIDAS nGen is that we can work on multiple projects at the same time on the same window. Finally, I'd like to come to the unit system, which is kilonewton meter for now that I'm going to be using, but it can be modified at any point of time throughout the entire session, or from modeling to the analysis and design. So you can modify the unit system anytime. And you can go to various views from here, as well as you can click on the scroll button to access to all the views wherever your mouse is. So it actually makes it very convenient for us to move into different views easily at any point of time. Then further, we have got 3 modes of modeling, that is 3D, plane mode and story mode. Today we will be working on 3D and if necessary plane mode. And there is no need of story since this is not a building structure, it's a general structure, so no need to create any story information as well. So that's about the user interface of MIDAS nGen. And now let's go ahead and check out how to do the modeling in MIDAS nGen. So before I begin, let me tell you that there are many ways in which you can create a model in MIDAS nGen. When it comes to buildings, you can use this tracing file import, wherein you can have architectural drawings traced and you can generate the beams, columns and the shear walls using the architectural drawing itself. You can also have DXF or DWG 2D, 3D importing in MIDAS nGen, which can directly generate the elements, or you can also firstly create a sketch and use that sketch using importing function to create your members. Further, we have 3D grid line based modeling. You can create a 3D grid line and you can start modeling using it. You can even convert the grid lines into members. Then further, we have got importing functions, like you can have Revit or Tekla files imported in MIDAS nGen. Stat files as well as parasolid files can be imported in MIDAS nGen. Further, we have got wizards also available, PipeRack 3D assembly shape that is there in MIDAS nGen and very useful. And today we will be seeing how to create a box culvert using our wizard itself, so that it will be very fast for us to do the modeling. Then there is another way of modeling, that is by directly creating our members using coordinates, or you can even start sketching in the plane mode. Alright, so that's about directly creating members. And lastly, we have the body type of modeling. As in, you can simply create your lines, faces, points as you wish, like a sketch you can draw. And then you can convert those lines, those faces into members like columns, beams, braces, slabs. So it's actually very useful, and we have got all CAD type of tools for easy editing of the model. Also some generation tools are available, and Boolean cuts and all these operations are available for accurate modeling. So let's go ahead and start the modeling of our box culvert using the wizard tool. So in this wizard, we have got the 3D assembly shape, which has various numbers of predefined shapes. There is a cylindrical one, and we have conical ones, and dome-shaped, and there is box-shaped, and so on. So what we will do today is we will use this box shape for our box culvert and provide the information. So I would say this would be the height or length. So our box is actually going to be horizontal. We will change the angle later on. So let's simply provide the distances. So this one I'm putting as 6.2 meters. Then further, we will have distance of, this will be the height, so that is going to be 3.3 meters, and this will be the width, so that will be 3.25 meters. This is an example I'm taking, so that's one thing. And you can click on add over here. Alright, so before you click on apply, you can see the preview. You can change the direction over here, make it as global X or global Y. So as you wish, as you would like to put it in your model. And also you can change the start point. This is 3.3 meters, so you can make it maybe 1.15 as a height, so that you can have the level upwards. Alright, so that's, sorry, let me change it because it is in green color, so it is detecting my mouse. However, I'll make it 1. Sorry, that would be 7.5, 6.5. All right. And after that, we can simply click on apply. Alright, after clicking on apply, we still have the box open with us. We can go ahead, create more numbers of box culvert, or we can create more numbers of members by using this wizard. And this wizard can be edited later on as well. So you can close it and you can edit your model after that. So by default, the program creates shell type of element. Let's go to the closer view. Alright, so we have a shell type of element, and now comes the part of thickness. Okay, right now by default the model has some predefined materials and thickness properties. So we have S275, that is the steel material property, and C3037 as the concrete material property. And further we have some sections, predefined ones, and we have thicknesses also that are predefined, so 150 and 300. So if I hover over T150, you can see that all the elements or all the members are getting selected. So in this case, I can understand that this is nothing but 150 provided to all the members. So I can edit this and I can say modify and further provide over here a thickness. So I'm having thickness actually of 230 mm for the top. So I'll click on OK. But I have different thicknesses for my side walls and my bottom. So for that purpose, we can go ahead and let's say modify this 300 to 0.25. And we can select this plate or this shell member and drag and drop the property anywhere on the workspace. So in this way, you can see that the thickness has increased and we have assigned successfully the property by simply selecting and drag and drop. Alright, then I'll add another thickness, which is going to be for the sidewalls. Alright, so this one is going to be 200 mm. And I can also modify the name. Instead of T200, I can say sidewalls, like that. So it totally depends on how we want the names to be, if it should show what is the thickness or if it should just name where it has been applied. Alright, now the sidewalls thickness is going to be applied to the sidewalls. So I select them and drag and drop. Okay, we have got an autosave feature in MIDAS nGen. So I'll just save it and it will get saved after every 1 minute. So that also is totally dependent on us. We can adjust the saving time. Alright, so I was at assigning the sidewall property. Now, there are two ways in which we can assign the properties that we have just defined. One way is by drag and drop, which I have already shown, and another way is by going to the properties menu. Alright, so we have the properties menu wherein the same properties are applied to two sidewalls. So we can just simply change the thickness from here to sidewalls, and that's it. So this is also a very easy feature. Now if you would like to see the thicknesses applied to various members with the help of colors, then you can go to this view control right over here and you can change this viewing option, this viewing color mode over here as by property. Okay, so that's done, and we can see here different properties, different colors for different properties assigned. Alright, now we can go ahead to the next part, that is skewing the box. So we have straight box right over here with us. We want to skew it. So for skewing, okay, there's like different way. You can either select this and one by one move each node or each point. Or what you can do is you can apply a body point at each location. Now these are less numbers of locations, that's why. So I'm creating point at each location and location of this face, alright? And after that, I press escape to come out of the command, and I can go to the isometric view, or let's go to the top view itself. Alright, now after that, I'll just simply select these points and move them. Alright, so simply selecting these points and moving these points will also move the members along with it. So this is actually going to be somewhat 0.9, and I click on enter. And that's it. It's a simple way of making a skew for our bridge. Alright. Otherwise, you can model directly different members and then you can apply the skew, or rather you're making the skew along with your model generation. So it's like totally dependent on how we would like it to use it, depending actually on the model. Alright, so we are done over here. Now we'll go ahead to the next part, and that is going to the member and looking at the measurements. So we can see over here the measurements of the two nodal locations. So we can click on two locations and I can find out what is the distance between them. So it's that easy. Okay. So after we are done with looking at the measurements, we can choose to keep these measurements on the screen, or you can have these removed by simply selecting and deleting them. Okay. Then further we have got checking. So it's really important actually to perform the check before you go ahead to perform the analysis. So let's firstly check our model if there are any duplicates, if there are any mergeable points. That means if the members are close to each other but not merging or not connecting. And then there is quick silver phase detection as well. So there is check duplicate members right now. Let's check all the members. So I'll click on check. Here also, I did not mention in the user interface, but at the bottom we have got the message window, and this message window tells us the information for our errors or warnings while we're giving any command. So we can see here there is no duplicated member. Also, we do not get anything in the list for duplicated members. So we are okay. And let's go ahead check with the non-mergeable points. The mergeable points, so there is nothing as such, all are well connected. And check silver phase, so we'll check that as well. Check silver phase, well, silver phase checking is nothing but looking at the phases that are very close to each other but are not joining. Like mergeable points, it's silver phase, like for the plates or 2D members that we have. Alright, so we're done with the checked model. Now let's go ahead to the loading part. Okay, so if you have any questions before we go ahead to the loading part, you can write at the questions box. Let's take a look at the loadings in some while. Another thing I would like to mention over here is about meshing. Meshing, usually in many programs we have to take care of the mesh size and everything, but over here we can actually ask the program to mesh it by itself, and we can, no need to do the meshing by ourselves. It will perform the mesh by itself while it is performing the analysis. So the software is actually a member-based software, and whatever you see over here is how you model. Alright, then let's go ahead to the loading part. So we are at the loading part, and the first load that comes to our mind is nothing but a self-weight. So firstly we are going to apply self-weight to our structure. Now here we have got different load sets that we can create, and then we can choose in our analysis case to be used or not to be used. So let's create this static load set separately for self-weight so that we can analyze the structure, or we can interpret the results only for the self-weight separately. So one self-weight load case. Alright, so another load case that we'll have over here is going to be for the maximum earth pressure. And we can actually put it into the earth pressure load type. Then we'll have minimum earth pressure. Then we can have vertical earth pressure. And we'll have a live load surcharge. And further we can have water load as well. So you can actually put it under the buoyancy, or you can put it under the groundwater pressure loading, or yeah, I think that would be it. Alright, so let's put it under the groundwater pressure. And further we can go ahead, create some more static load sets for our moving loads. So for moving loads, we are going to be having moving load case, just MV and add. Alright, that's not going to be under the groundwater pressure. I'll put it under the live load itself. And select this. MV, live load, and modify. So we have got over here all these loads which we can utilize. These load types that we have over here, these are actually depending on the load combinations that we're going to make. So depending on these load types, the load combinations will be created. However, in box culvert in MIDAS nGen, it would be required to create the load combinations by ourselves because we have over here building codes other than the general codes. So for general structures, you can create your own load combinations. Alright, then let's go ahead. We are done with the sets definition. Now we have selected the sulfate for our sulfate loading, and there is a -1 scale factor for the sulfate. We click on OK. Now the sulfate that we have applied on our model can be viewed with the help of this blue arrow, big blue arrow here. And also you can see it in the analysis tree menu. So in the analysis tree menu, you can go in this static loads and you can expand the dead load, and you can see the sulfate right over here, and this indicates that you have applied sulfate on your structure. Alright, then further let's go ahead to the next loading, and that is about the earth pressure loading. Alright, so here we can go to the earth pressure and we can firstly define the earth pressure functions. So here we have earth pressure, let's say maximum function that we want to apply, and for that we are going to specify the load parameters. The parameters required would be the ground level. So this is like it is underground, so the height should be provided over here of our box culverts, which is 3.3 meters. Then you can also apply the water level if there is any water pressure from outside the box culvert. We are going to be having water pressure from inside the box culvert, and there is no water level outside the box culvert. So that's the assumption that I've done over here. That's why I'm keeping the water level 0 itself. Then there is bottom level. So this is 0 location, that is the bottom level. Then the density of the soil. So I'm putting 19 kilonewton per meter cube as the soil density. Then the internal friction angle, putting as 30 degrees. And for additional load on ground, I'm putting it as some 50 kilonewton per meter square. And then after that, we can click on calculate. Alright, so after we click on calculate, we can see over here, this is how the loading is going to get applied. We are going to have 25 kilonewton per meter square at the top, and we'll have 56.35 kilonewton per meter square at the bottom. That's how the pressure will be variating from the top of the box culvert side walls to the bottom. Alright, so this is how we are going to be applying. If you in case want to make any changes in this, you can directly specify the values over here. For example, if this is going to be 17, then you can make it 17 and likewise. So this is just an example that I'm making. Alright, so I'm calculating and using these values itself, and I'll click on apply so that I can define the next earth pressure function. Alright, so then the next earth pressure function is, let's say, EH minimum, and I'm providing the same information, except I'll be providing over here with a lesser ground load, let's say of 25, and I click on calculate. Alright, so this is how I'm going to be applying minimum earth pressure, and I'll click on apply again to finish. Now here we can apply a separate water load which is going to be from inside. So you can apply it as a water level or you can apply it as an earth pressure itself. So that's not a problem. Basically, you can provide the same information except you can change the soil density to 10 and then no friction angle and no additional ground, and then click on calculate. So accordingly, the program is going to be multiplying the height 3.3 meters with the density of the soil, that is 10. So in this way you have control over what you're defining, what the density of your water. Alright, so that's one thing. So we'll see that this is 0 to 33 in case of earth pressure. And we'll be done over here. Alright, I got a question over here about the material properties that we have selected, and yes, actually you're right, we have selected incorrect material property. So there is 275 that has been selected for the side walls. So I'll just modify it quickly to C3037 and click on OK. So now it's right. Alright, thank you very much. Okay, so that was about it. Now also there is application of the earth pressure. That's what we will do now, and we will go to earth pressure right over here, and we will select the function that we have just defined, and we can also name the earth pressure as EH max and all. So that's the point, and then let's select the plates. Yeah, it's important firstly for us to make all these members as plates type of member. Right now, because of the wizard, all the members over here were shell type. So you can simply select all these members and you can see all the information regarding the shell. Alright. So here you can see that the member type basically of our 2D elements is shell. So we will change it to plate so that we can apply the earth pressure load on them, and also we can perform the design for plate elements itself in MIDAS nGen. So let's go ahead and apply our earth pressure on our plates. Yeah, so we are going to be selecting this one side plate and we are going to be adding it. So as you can see over here, the load preview is done and it is from inside to outside, which is not what we want. So let us delete it and reverse the direction of this plate and click on add. So now we have the application from the outside to inside. Alright, and also let us select this side wall. And there is no reverse direction for it, so let's just click on add. So we can see here it's again from inside to outside, which is not what we want. So again we can reverse it and modify it. Alright, so we are done with the reversed elements, and okay, and EH max is the name of the loading I would like to give. And the earth pressure function that has been selected is the same, and if there is any scale factor you'd like to apply, then you can do that. And if there is any earth pressure that you'd like to apply on the top, you can click on select plates and then apply it. However, we'll apply it separately for the vertical earth pressure. So I'll click on this apply button right over here. Alright, and we'll select the EH minimum, and over here EH minimum as the name, the function EH minimum, and plates again the same thing. We'll select, reverse and add, and then click on apply. That's done. And lastly, we have got the vertical earth pressure, the water pressure. So WA is what I'm selecting, and WA function as well, and I'll provide the name as water load. Now this water load is going to be from inside to outside, so I'm simply going to select these and there's no reverse and click on add. Alright, so now we can see over here that the loading is from inside to outside. So if I would like to check all the actual loading that is going to be applied, Okay, so it's from inside to outside, and that's what I want to apply. And then we can click on OK. So we have all our loads, inside, outside pressure loads inclined to our water, to our wall. Now let's go ahead and apply the pressure loading that is going to be from the top. Alright, now here we are going to be applying the vertical earth pressure on the horizontal face at the top. So I'll select E and we'll select the top of our box culvert, and this is the normal direction. So we are going to simply specify the pressure value over here. So yeah, the pressure value is, let's say, 50 kilonewton per meter square, and then we can click on apply. Then further we are having some live load surcharge. So this live load surcharge value, it's 5.7. So what we'll do is we'll select this side. Let me undisplay all the static loads that already applied. So we have selected this side. It's normal, 5.7 kilonewton per meter square. All right, and that's how the load is going to get applied. And let's undisplay the thickness. All right, and we'll click on apply. So as you can see over here, the pressure loading is applied to the side walls. Uniform pressure loading is applied to the side walls with the help of pressure loading. And then we'll click on. So we are done applying several loads on the structure. Like we have got the earth pressure loading, EH max, EH minimum, EH. Then we have the live load surcharge loading as well, and box culvert. Next comes the part for application of the moving load. There seems to be some technical issue. Okay, now it's resolved. Alright, so we have over here our loading. Let me display then in that case the loads that I have applied and quickly get to the moving loads again. Alright, so we have applied the sulfate, which was shown or displayed in this way. Then we have the earth pressure loading. So you can see this is the earth pressure loading applied. And if you would like to actually look at the loads applied on this, on these walls, you can go to the view control right over here and check on the load value and just click anywhere back on the screen. So now you can see at the top it's 25 and at the bottom it's 56.35, and that's the earth pressure load that we have applied to our side walls. So on both the sides. So that's about the EH max, then EH minimum, earth pressure minimum. And similarly, we have vertical earth pressure 50 kilonewton per meter square. Then we have applied the live load surcharge loading, that is uniform pressure of 5.7. And we have applied the the water load actually from the inside of the box, that is 33 at the bottom and 0 at the top. So these are the different loadings that we have applied until now on our box culvert. Alright, and now we will go ahead to the moving load application. Now in MIDAS nGen, moving load analysis is not available. However, you can send your models to us and we can provide you with the critical location of the moving loads, because in MIDAS Civil and MIDAS Gen, the moving load analysis is available, in which the program suggests you the critical location of moving loads. If you by yourself have done the moving load analysis and know the location of the critical loads, then you can directly apply it to your box culverts. So To apply the loadings, there are various ways. For example, you can apply the loads using arbitrary loading on your surface element. So for that, let's say, for example, okay, you have body type of element, and in this body type of element, you can go to create line. Okay, now it'll be easier if we go for a plane view, so that if we work on the plane, then it will be easy for us to actually apply the loads and create the bodies as well. So to apply the pressure loading or point loading or line loading on your surface, you can create the body type of elements. And on these body type of elements, you can apply the arbitrary loads. So that's what we're going to be doing. Since I had already performed the analysis using HA and HB loading, auto loading, on a 3 meter span, a 3 meter wide lane. So it's going to be at the center. So I'm going to be like making a line in the center. So the program has automatically taken the center points of my box culvert. And then on this line, I have calculated how the point loading is going to come. Or you can have those 4 lines created on your box culvert itself and then apply the loading by using points, or you can apply the loading using UDL on the line. So right now I have the information regarding a point load, like 2 point loads on my line. So firstly, I'm going to be creating a point right over here, and then I can copy my point at certain distance. So that will be like a relative distance. So I'll just move this arrow on this side, and I'll provide a distance over here of 1.5. That's the location. Sorry, that is going to be 1 meter, and apply. And after that, I'm selecting this point again to copy. And I'll again move this arrow right over here in the X direction and provide a distance over here of 1.5. So that's basically the locations of the moving load point, concentrated moving load, so that I get maximum moments at the center of my box culvert. So it's just a predefined analysis that I had performed, which now we are going to apply on our structure. So using the load tab and the arbitrary loading, we have point load. Alright, and in the point load, I can use the MV load set and select the points. So I'm selecting this point as well as this point on which my loading is going to be minus 390 kilonewton. That's what I have got. And then I'll click on OK. Now this load is going to get transferred to the surfaces after the mesh is created. So we need not worry furthermore. We can simply go ahead now to the boundary to apply the supports to the structure. Alright, so let's go to the 3D mode now to apply the support on our structure. So firstly, we are going to be going to this area definition for the soil springs. Now there are actually various ways in which you can apply this area soil springs, or you can have soil structure interaction. There is one method that is soil support, wherein you can actually assign the soil springs to the foundation type of members. Alright, so you can actually convert your bottom member type as foundation, and then you can apply the soil spring on it, which is tension only or compression only or linear type. And those, let me just show you that over here. Yes, we have the property which can be, we can define it with the help of the compression only vertical spring constant and the horizontal spring constants thereafter. So that's one method of applying the soil springs. Another method is using the Ball's equation. The program will automatically calculate the spring constants, the vertical as well as the horizontal spring constants with the help of the formulae that have been mentioned right over here. So you can actually just provide over here the information like the soil bearing capacity. Let's say the soil bearing capacity is 200 and the safety factor that you would like to keep is, let's say, 1.5, and accordingly we can get over here the vertical spring constant as well as the horizontal spring constant. So this is how you can use the Ball's equation, and also we have the Korean standard in which you can use, which can be used, and then further you can apply the soil springs to the box culvert. So this is one way, and it can be applied to foundation type of member. Another way is to use the plate type of member and apply area springs. Alright, so in area springs we have got the option to convert our area spring to the point spring supports, and we have the option to convert into elastic springs. So in case you have got any bearings, then you can use the elastic spring constants as well. Alright, so for now I'm going to be quickly assigning the area springs linear type to the plate elements or plate type of members that we have over here for our box culvert. Alright, so it totally depends on how do you want to utilize or what kind of analysis you would like to perform. So I'm going to be providing over here the information. So right now I'm using 18,000 kilonewton per meter square cube for my kx, that is vertical, and in the other two directions I'm going to make it ky and kz as 6,000 and 6,000. So basically the kx is the vertical or along the axis of our spring, and ky and kz are perpendicular to the axis of our spring. So that's how we are going to be utilizing, that is kv and kh and kh values. Alright, now let's simply select our plate element, and as you can see over here how the loading is going to or how the support is going to get applied. So accordingly, this is whatever you see over here is not the number of supports. The number of supports actually depends after you perform the analysis. So what you see over here is just the display for application of the area springs. Alright, so click on OK, and we are done applying the point spring supports, linear point spring supports to our box culvert. Now we will go ahead to the analysis part. And in the analysis part, we are going to be firstly going to the analysis settings, and in the analysis settings we will take care of the mesh size. Alright, so in mesh size we have lengthwise, wherein we can specify the distance, the size of the mesh. Then there is division, there is smart size as well, where the program will automatically take the size into consideration for the box culvert depending on the size of the entire model. So right now let's take length and provide, let's say, 0.5 as the size of the mesh, and we will go ahead. It's 0.25 I would say. Okay, you can keep it L by 10 to L by 20. That's the optimum size that we always refer to when it comes to MIDAS Gen and MIDAS Civil. So anyway, let's go ahead, 6.25, and we will see over here how the optimization of the surface mesh is going to get. So the element size growth rate is 1, optimization level is 3, and we can, it's the highest optimization level, and also we can see how you'd like to make the mesh, if it's only triangular or only quadrilateral or triangular plus quadrilateral. Most accurate meshing comes with the triangular plus quadrilateral when it comes to a curved type of a geometry. But if you have got a simple box like we have here, you can use the quadrilateral type itself. Okay, so this is it, and further an advantage to MIDAS nGen is that we can have number of processors. It's actually an advantage for all MIDAS software solutions. You can use number of processors and GPU accelerators to reduce the time of the analysis. So usually when it comes to big structures or where a lot of meshing is involved, at that time, and also the non-linearity, like we have non-linear springs. So for that case also, the analysis time increases a lot. So to reduce that analysis time and concentrate more on the design part, you can actually make use of these processors for the solver. So the speed of analysis actually depends on your hardware. So the analysis settings are done, and now let's go ahead to the static cases. So in the static cases, we can have n number of static cases applied. So you can actually make one static load case for the earth pressure only, EH maximum only, like that, and you can click on apply, and you can make another load analysis case when you have minimum earth pressure. You can click on apply. You can have number of load cases, loads, moving loads defined on your structure, and you can perform analysis of all those moving loads one by one and perform the analysis and check the critical one. So there are many ways in which you can actually find out the critical location of moving loads in MIDAS using MIDAS engine itself. And you can perform some research studies like iterative analysis in MIDAS engine. And those iterations are nothing but like modifying by ourselves and performing static analysis itself. So these are static analysis itself. We'll click on OK, and then we'll go ahead and run the analysis. So we have all these 3 analysis cases with us. We can choose which one to run, and we'll click on OK. Also, we can choose to have separate type of support condition for one analysis, another support condition for another analysis. So you have like a variety to do in MIDAS engine. For the same model itself, you do not need to save as and run another model, or you do not have to work on 2 different models at the same time like that. Just one single model we have, and we can see now the mesh also, how the program has taken care of the connectivity as well. Alright, so let me go back to the analysis tree menu and uncheck the springs to undisplay the springs, as well as I'll uncheck all the loads that have been applied. So no loads on the structure, and let us see the thickness, and along with the thickness, let's look at the meshing. So mesh edge is the option. Alright, and now let's take a look at the analysis results. So the analysis results can be displayed in the analysis results tree menu, which will be generated after the analysis. And from here, you can check out the deformation like dxyz for only self-weight. Then you can look at the reactions as well. So this is the reactions wherever the supports were applied and however the analysis, the meshing was performed. So that's the pressure. Then you can also look at the, these are the forces. You can also look at the applied forces. So these are the applied forces for each and every node if you'd like to utilize it anywhere. Alright. Then similarly, we can see the results for different analysis cases, like let's say for the moving loads, what is the displacement of the structure in the Z direction. So that's one thing. And further, we can also see the plate forces. So let's look at the bending moment. So this is the bending moment for the live load. That is, the moving load, not the live load. And also we can get the results for the plate stresses, and we can then check the maximum shear stress. We can take a look at the normal stress results, the principal stresses at the top, principal stress at the bottom. So it's like you can actually take a look at the results at top and bottom separately of the plate elements. Von Mises stresses are also there. Then further we have the results separately for analysis and design tree. Alright, now what we can actually do is we can create load combinations. Let's go to the design part and create the load combinations. We can create load combinations before like going from the analysis as well as from the design tab. So those options are available. Now we'll create load combination over here. If there is any load combination that you can use out of these load combinations generated automatically as per the Euro code, then you can make use of it accordingly. Alright, so there are serviceability and limit state type of load combinations for RC members, and I'll click on close. Alright, and then let's go ahead and create a design group so that we can get the results, the design results for every group of members. So I'll make an auto-generate design group right over here, and before that let me save my model. Okay, so I'm setting auto select and click on OK. Alright, so we have got different design groups for each and every plate, and then let's go ahead with the member parameters for the design purpose. And here we can actually specify information like the target ratio for our plate results like tension, bending, shear, and according to these target ratios the program will automatically tell us with the help of contours how the design results are. Then further, how you would like to perform the design with the help of flexure the design, or you would like to take the axial as well as the flexural forces for designing. And if you'd like to have plate forces adjustment, that also can be done. Alright, so right now let's go ahead and perform the design with the help of a design case definition. And we can have multiple numbers of design cases as well. So you can use one design case for analysis design 1, one for analysis design 2, and another for design 3. So likewise you can do also. You can unselect everything and you can use the select from view to perform the design for any one of the selected plates and click on OK. So this is how you can have just one plate member designed. Right now I'm going to be designing all and clicking on OK. And then let's click on Run Design, wherein you can check on the rebar auto arrangement where the program will provide us the location of the arrangement of the reinforcement. So click on OK and we are done with the design. Now let's go ahead and check the design results. So firstly there is status. So status tells us which element or member is failing or is not passing. So we have over here the options like, the results. The red color says not good, that means they are failing. The blue color says okay, and the yellow color says critical. Alright, so we have the results, all types of results right over here for which we can check the results, the detailed results. So let's go to the serviceability check as well and look at the results status. So here we can actually get the crack ratio, deflection ratio results, and this is all available only if we have assigned the proper load combination to it, and also we need to assign the serviceability check parameters to these members. So it totally depends if you would like to perform the serviceability check or not. However, right now for this webinar session I'm showing the ultimate limit state strength check itself. Now let's look at the design results. So we have over here a flexural member, which is a plate type of a member. So we can see the ratio over here. Oh, sorry, this is for axial plus flexural. Only for flexural, that's what we have. So I'll double click. So we can see over here what is the ratio for the axial, not for the axial, but the bending moment in the negative x direction. And then in the positive x direction, so we have failure in the positive x direction. Then the y direction fail, if there is any failure. Yes, no, there is no failure as such. So there is 0.9 is the maximum one, and 0.92 again for y is not failing. Let's look at the shear results. So yes, we have failure in shear and in x direction, and also in the y direction. Right, so this is basically giving us the idea of demand to capacity of our members and the loads coming on to them. Now let's take a look at the design results. So we can go to this, like what reinforcement arrangement is there. So RC section, And here we will go to plate bending, and we can see over here this is the arrangement provided by the program. So there is top diameter is 16 and it is spaced at 400 mm distance. Then bottom is 16 at 150 mm distance. So this is the main rebar arrangement in the X direction. Similarly in the Y direction we can see here, and the shear reinforcement that has been applied. Now all these things that you see over here can be modified by us as well. Like over here we can see that the program is telling that this particular member is failing in shear by 1.35 times. So maybe we can choose to increase the thickness of that member. So for that, let's say it's 300 mm. And then after doing the modification, we'll click on design modification member. The program will check again and it will tell us the new result, which is at the bottom, which is still failing in shear by 1.24 times, 0.24 times. So that's like the result that can be displayed after we do the modification in the design part itself. So that's it. After you're done with the modification, you can also go ahead and say update, so that the program will automatically modify the thickness that we have just modified to 300 mm, and then we'll have to again perform the analysis and design. So that can be done by simply clicking on run all, and you can say rebar auto arrangement, compare and replace previous data. The program will again run the analysis for all three types with the help of 300 mm thickness of the member that we have modified, which is plate number, this plate basically, PL to PL1. Alright, and now the design has also been performed. So let's check the result. Alright, so after doing the modification for this member, we have over here, okay, it's the bottom member actually. So as we hover over this particular row, you can see which member it is talking about. So we have this bottom member which is 300 mm now, and its final ratio is 1.29. So you can further increase or check with the loadings that you have applied or the soil spring support that you have applied to your members. So this is how you can get the analysis results and the design results for a box culvert. In addition to what we can see over here, like in addition to our simple box, you can also have wing walls added to it by simply sketching and creating faces or plates. It's like creating a model using AutoCAD. So it's very simple. Just need to visualize what you need to actually do and create 2D elements, 2D members at any location that you wish. And the program basically will take care of the connectivity of the members. Alright, so that is it regarding the box culvert. Let me get back to the presentation. So today we have actually seen how a box culvert can also be created in MIDAS nGen. And the chamfers, as you can see over here, can also be incorporated with the help of inclined plates or in between, or you can also have line elements that are in this particular shape, and you can get it passing from this end to the other end for all these 4 locations. So it totally depends upon you if you want to make it like really accurate, or if you would like to leave it as straight at the top and the sides. So there are options to make it just the way it looks like over here. Okay, so that's one thing. Now let me tell you about the support that MIDAS provides to our users. We have our training videos available online. There are video tutorials, and we are conducting webinars like we have conducted these 4 sessions. So if in case you would like to have any support requirements, like support for your office, then you can definitely give us a call and we can arrange for a specific webinar session for your specific topic. All right, let's conclude our webinar session today. So we have seen over here how the shape model can be actually created along as an analysis model in MIDAS nGen. That's the integration that we have. Then using automated features, we can do the modeling in a very fast way. And then further, we have analysis and design system for optimal quantity in case of RC and steel buildings. And further, there are high quality reports and drawings that can be generated. So in the previous sessions, we have seen how the reports and drawings were generated by the program. Lastly, let's take a look at the special launch pricing. MIDAS nGen, which can help you with steel buildings, RC buildings, as well as general structures like we saw today, box culvert. So you can get the entire modeling of the superstructure as well as the substructure done in one single model. You can have a number of analysis cases done and do the iterations by yourself and get to the conclusions in a short period using automated features. So when it comes to buildings, we have the architectural drawings that can be incorporated to do the modeling, and at the end you can also generate the structural drawings. So in these last 4 sessions, we have seen about all different types of structures that can be incorporated in MIDAS nGen. And all these things you can get only at the price of $1,200, which is actually a launch price. The original price is $2,400, so $1,200 is basically the 50% of the original price. And this launch offer is valid only till 31st March 2019. This is the last month. So if you're interested, you can definitely make the best out of MIDAS nGen. And you need not worry about how to work on this software, since it's a new software, a new technique is there for modeling and analysis and design and everything. So you need not worry about how to incorporate it in your day-to-day life, because we will be there, the support team will be there to support you for your projects. So you can actually bring up your own projects at our global support. That's our website, globalsupport.midasuser.com, and we can guide you throughout your entire project. So the trainings and technical support, it is free of cost. It is included in the price. And yes, important part in this price is it's a subscription pricing that is available for a year. All right, let's go to the question answer session now. So for the question answer session, I'll get back to MIDAS nGen over here. All right. So we have a question about the stiffness modifiers when it comes to shear walls. So let me go to the pre-processing mode firstly, and we will go to the define. And we will firstly define over here the stiffness reduction for the wall. So that's the question, how to define the stiffness reduction factor for the wall. And here we have the options to scale the axial shear in itself. There is no option to have the stiffness change for the shear and bending outside and bending inside and outside as well. So basically this is because in MIDAS nGen, wall is actually considered just like a membrane when it comes to a stiffness scale factor reduction. So if you would like to make modifications, maybe use stiffness scale factor for the shear out, bending in and out and all, and you can make use of the slab type of member, and you can apply those scale factors for those members. So that's actually just a crude way of applying the wall stiffness factor to the shear wall members using the slab. So that's not exactly how it's supposed to be, but it's just another way around. Another question is about tutorials for swimming pool in building. Yes, we do have. If you look at the high-rise structure, let me open up the website actually, so that it will be, the website is en.midasuser.com. Alright, so in the website itself, there is a training and product tutorials. And in the product tutorials, you can go to MIDAS nGen right over here. And from MIDAS nGen, you can go to this high-rise reinforced concrete building tutorial. In this building tutorial, it has been actually shown how a swimming pool can be incorporated in a building itself. So there is a swimming pool right over here that you can model by simply following this tutorial. All right, is there any other question that you would like to ask before we are closing off with our webinar? Okay. Another question is, how can we check the scale factors? So the stiffness scale factor, I suppose that's what you're asking for. So over here, like, we have the option to just simply go down, and after we apply the stiffness scale factor, then only we can see if that scale factor has been applied. So if I am I'm at the member tab, if I apply assign member stiffness scale factor, and then I apply it to the wall, or you can apply it to the slab. So I can select this plate over here as well and assign this stiffness scale factor that I have defined for the slab and click on OK. And after I have applied the stiffness scale factor, then you can click on that member and then you can see it at the bottom right over here. So this is where you can see if the scale factor has been applied or not. Alright, we have got another question about how to model staircase. Well, to model the staircase, we can make use of the inclined slabs itself. We do not have predefined staircases as such, which can be defined directly inputted in the model. But you can actually have your staircases modeled as slabs itself. So those can be inclined slabs. You can have incorporation of intermediate landings and beams, and you can perform the analysis and design the same with the help of loading. So the loading that will be applied on those plates will be nothing but a plate loading, which can be applied in a vertical direction. pressure loading, which can be applied in the vertical direction. Also, if in case it's a slab itself, like a slab type of element you're making, for which you can get the one-way, two-way type of design, so you can apply the slab loading for the staircase as well. All right, thank you very much everyone for attending our MIDAS nGen training sessions. All the videos must have been already reached, but today's webinar session is just recorded, so it will be reaching to you very soon. And we hope to have such kind of great attendance in our webinar sessions, and it's good to know about your interests as well. And hope to see you again for further training sessions. We can have one-to-one training sessions as well as you require, and you can write to us your queries. So thank you very much again, everyone, for attending the webinar session. Have a great day.